Hey guys, welcome back to my channel. Today in this video, we will be talking about the machine learning. But before that, I am back after a long time. I think 13 to 14 days, and I miss you a lot. So from now, I will be regularly uploading the videos related to machine learning, and now we will move towards some automation in a sense that I will upload machine learning and deep learning videos. But before moving into the main agenda, I want to thanks to all of you because you have supported me a lot. You have given me that opportunity that I can teach you, and you have also subscribed my channel, like these videos, for all these things. I want to thank you. I want to say the only thing which is thank you. And today we will be talking about the machine learning, and we will master the machine learning in 15 days. And today is the first lecture. So today we will be talking about the agenda, which is first of all, we will explain what is machine learning. It will be a broad introduction. Then we will talk about what are the types of machine learning, supervised and unsupervised learning. Then we will talking about linear regression. Then we will be moved towards some practical implementation. So what is machine learning? When we actually listen about from someone about machine learning, then the first thing is which comes in our mind, how machine learns. Because and today I will explain everything with the help of an example. Machine learning is nothing but a field of artificial intelligence in which we use the statistical models to learn from the data and predict the future data based on the given data, produce the future information or data based on the data in which the machine learns. For example, I have a machine learning model called linear regression, and linear regression used to find the linear relationship between the data. So it will take the data here, it will find a relation, and it will actually generalize. It will find the patterns in this data. It will find the patterns in their data. On those patterns, it will predict the future data. For example, I have a data set which contain the houses names, their respective location, and with the price. So with the help of the houses names and the location, it will predict the price. So what it will do, we will give the houses price and the location and everything to the machine learning model. He will find the patterns, hidden patterns, which means that if the house is in the London city, I will give you example, then it will be high price as compared to the as compared to a Chicago or some other city of any country you can compare it. So here it will actually make a patterns, and based on these patterns it will predict the data. Now where we use the machine learning we use in all platform, always in all platform. Whenever there is a name of automation, when there is a word of automation, there will always be machine learning. Okay, it can be healthcare departments, various fields. We can use in healthcare to detect the, to diagnose the disease, to find out the diagnosis of disease. We can in fact use in the finance to protect ourselves from fraud. We can use in self-driving cars and all these things. So let's talk about what are the types of machine learning. So in the machine learning, we generally talk about three types: supervised, unsupervised, and reinforcement learning. These are actually the three types. And in this video, I will only explain you supervised and unsupervised. But in the future videos, we will also cover the reinforcement learning when we move on to the deep learning. Okay. What is actually a supervised learning? Supervised learning, which means from your word, you can assume that in supervised learning, we will be both have the X data and Y data. What are X and Y data? X is actually the data in we which want to predict something, and the something which we want to predict is actually the Y data. For example, you can take an example of this in a sense that we have already question and we have already answers. Our model will find out, will it will learns the question and answers at the same time, and it will predict the next question answer based on the answer which we have given to our model. These are called the label data. In the next slide I will explain these things. And it contains the algorithm, just like it focus these algorithm leads to predict the house prices. As I explain you the house prices example, in which we have house names, house cities, and along with the house prices. So house name and house cities are actually called the X data, which will be used for the prediction, and the house prices are actually called the Y data. And in supervised machine learning, we both have X and Y data. So let's move forward. Now it's an example of supervised learning. X1, X2, and up to XP. XP means it can be any number. These are actually called the dependent independent features. These due to these independent features, we can predict the Y feature. Okay, and it is actually the basic architecture of supervised learning. So whenever someone asks you about supervised learning, you can tell them it supervised learning based on works on the label data in which have we have all X and Y. Okay. Okay, now let's move toward the next problem, which is called unsupervised learning. The unsupervised learning, we have data without labels. Now this is very one of the interesting thing. One of the interesting thing, you it will assume like I have my paper and I don't have the answers of those questions, and I need to figure out these answers by seeing the questions by some patterns. So how we so in the for this purpose we use some type of clustering techniques, and we can use some recommendation system. You know about what is a Netflix recommendation system? It actually takes the one user's data and it find out the hidden patterns, and it predict that data to the next user. Okay, it actually find out the hidden patterns in that data, and it's called the clustering. What it will do, for example, I have a three groups here. I have put the data which contain data scientist group, data analyst group, and data segment and database engineers group. So what it will do, it will find out the similarities in these things and it will group them. So data scientist will be at one side, data engineer will be at other side, and data analyst it will be third side. I did not tell them that what is the data scientist, what is a data analyst, what is the database engineer, but it actually find out the similarities in these things. Based on similarity, it divides them into the cluster, and therefore it is called the unlabeled data. Because unlabeled means I don't tell them what to do, it will automatically make a clusters of the data, it will automatically solve this problem. Okay, recommendation system, customer segmentation system, which means that separate the customer based on the products they buy. So these are the example of unsupervised learning. Okay, so here at the next slide, as I told you, we have only the features and we have no target variable which we want to predict. Our model, what will you do? It will found out the hidden patterns in these features, and based on these features, it will create one of its own target column in which it will perform some clustering. As I told you about data scientists, data analysts, and database engineers. Okay. Now let's talk about the linear regression. Linear regression is actually a supervised machine learning model which is used to find the relationship between the independent and dependent variables. So dependent variables are nothing but the y which we want to predict. It refers to the value which we want to predict. And independent feature are those which will be used for the predictions. These are called the x. X is independent feature, x are independent features, and independent features cannot be one, it can be many, but dependent features is always be one. It will always be one, it can be two or three. Okay, so linear regression find out the relationship. Now there will be a question in your mind, how it find out the relationship between the data. So what will you do? It will first of all plot the data. For example, I have a x-axis some data and at the y-axis some data, and these are some of the points. So it will create a best fit line here. It will be a standardized line in which will be used for the prediction. So why it will create that best fit line? That best fit line is nothing but it will show the linear relation, it will show the linear relationship between the data. Now, how it will find that best fit line? With the help of this formula. What will you do? It will take, first of all, it will take all the x values, and it will add the x values with some sort of logical values which are called the coefficients. Okay, coefficient 0 we always consider it, sometimes we consider it as 0, and b1 and xi means the element which it xi refers to all the elements, and here actually they made a mistake. At the place of b1 they need to put bi. So for example, the value of b will always increases when and it will always be equal to the x values. For example, I will use the pen tool here. The equation will be look like this. We want to predict the y. So for this purpose I have two features, x1, b1. It's the first feature. B1 is actually the coefficients, and these coefficients are equal to the number of the x values, and these are the logical values which automatically selected by in backend by our model. And we have x2, b2, and at the end we have xn, bn. So these beta values are nothing but the logical values, and this actually tell you that how many on which percentage on which rate our value depends upon. For example, if my x is if y is more depend upon x, if y is for example I have features here x1 and x2. So if I say that x2 more influences the y, which means that y is dependent more on x2, so the beta value of x2 will always be greater than x1, because whenever there is a high relationship, there must be a high beta value. Okay, now you understand what is beta. So in linear regression, we need to create that best fit line, and this will automatically created by our model based on the parameters we set in our practical applications. So this was all about linear regression. Now let's move towards the practical part, in which we will do the linear regression based on the data here. So let's move toward the practical part here. So in the practical part, I will first of all open my Jupyter notebook here. So in the Jupyter notebook, I will go to the desktop, and in the desktop, I already have a data set here. So I will already have, I actually, I already have, I think I have already here apply. I already here apply the linear regression on that data. So, okay, let's start. First of all, I have imported the data. I will not explain you everything because you already know everything, as I explained in the past videos. What, how to drop the duplicate values, what is the exploratory data analysis, and all these things. I will only tell you that how you can implement the linear regression on the data. Wait a second. First of all, try to remove all these unnecessary columns here. Okay. Now, first of all, I have a data here which is called. Okay, first of all, import the linear regression. I have imported this linear regression. Okay, I need to predict the income based on the city and gender. So at x-axis, I will make a logic here that I only want I want an every column apart from income. If you know don't know about these column dropping and all these things, I will recommend you to see my previous videos. There I will explain you all these things. I will not use in place because I don't want to replace I don't want to replace I don't want to remove the income from these columns, because I already want to store it in x. So what does it mean that I will take here income. So what if I click here the replace here in place? If I click here the in place, first of all, let's copy. Uh, let's create a new variable, and I will tell you what I will. For example, I want to drop it from here. If I click on the in place, then my column will not only drop from the x value, but it will also the drop from the df new. Yes, it has been already been dropped from df new. Okay. Now I don't need to put the replace here. It will actually I don't need to put the in place here. So I will run it here. So what does it tell me? Income is not defined, is not found in x-axis. So at the place of df new, I will use the df column, because at the df new I have removed the income. And here I will fit the model lg dot fit. But before that, we need to convert the data into training and testing from sklearn dot model selection. From sklearn dot model selection, import train test split, and here we will use x train, y train, x train, x test, y train, and y train, and y test. So here I will apply train test split. I will pass x and y here. The test size will be nothing but I will take at 0.3, and random state will be nothing but 45. If you don't know about these things, make sure to watch my previous videos. Now I will create an object of the linear regression here. Here is the objective of linear regression here. Okay, so I will fit it on the data here. I'll fit it on x train and y train. Okay. Now if I calculate the score, score means that what is the how our model fits on that data. If I calculate the score here, so what will you do, if I pass out the x test and y test here, x test, so the value is 0.0.9, which means that 9% of accuracy, which means that there is an error in our data, so that's why we couldn't get the accuracy. Normally the accuracy is round about r2 score is round about 90, and we are getting the 9%. So what does it mean? Okay, how to calculate a score? First of all, you need to calculate a score and you need to put the round value. It will actually tell you that what should wait a second, score, and okay, if I click here one, yes, yes, there, click here, zero, not, yes. So we have 10% of accuracy. 0.1 means 10% of accuracy. 0.2 means 20%. So here we have a 10% of accuracy. Our model is, if I multiply it by 100, then it will tell you, okay, this is the formula to calculate the r2 score. These the score, that score is nothing but r2 score, which we can use to check the accuracy if our model is fit or not. That 10% means that our model is fit, 10% fit on the data. For example, if I have a data here, uh, these are our wait a second, where is the line plot, which I will explain here. For example, we have a where is my pen tool, we have a data set here. Here is the pen tool. Okay, it will work. Wait a second. For example, take a here, take a data set here, take a point sum here. These are actually all my points, and my model is like here. So it means that it covers only 10% of data, but we need at least 90% of accuracy here, because our model should cover 90% of data. If it covers more data, which means it can give us a better prediction. If it not covers the more data, it gives us the problem which is called the underfitting. Okay, I hope you like the video. Subscribe my channel and hit the bell icon. I have applied here the linear regression, that model selector. I have explained it in my previous videos. Here I first of all import the class, create a class of the create object of the class. Then I use the fit function to perform the extend and y train. And now I can also predict the value. I can also predict the value. For example, I want to predict for the value of, in which the city is 2 and the gender is 0. So it will tell me that you have a value like 80,598 of price of salary. So 80,598. So we can also use it for the prediction. First of all, you need to create an object. Then you need to fit on the training data, and then you can calculate the score on the testing data. For example, we have to fit the model on the training, and in the testing I have calculated the score. And at the prediction, you can also do the prediction. You the double bracket and you can input the data.